So while this is coming up, which one is yours? Hello. Which one is yours? Data lake. There we go.
He was talking about like having
Hello, hello.
data, like your pod data, so you don't have to like figure out
They
how
will
it's
be
gonna
available,
work.
yes.
I wish Anthony again yesterday.
All right, and with that, so thank you, Jim. Appreciate that.
You're all set.
So Alex from Cisco Systems, the service owner of our enterprise data lake. Be sure to check out our booth. Data lake. Just want to see the faces for a moment. So we've been involved with this Hadoop journey now as a collective whole for the last 10 years. And if you think about some of the most compelling products that are coming out, you just heard about Kafka and the streaming that MapR is providing as well. These are absolutely the hottest thing and the coolest thing to be working on because of the use cases that are coming as well. Now that we have the world of IoE, digitization, we need these streaming capabilities, we need scale. And this is where I'm putting a lot of my time. But data lake, we're still having this conversation now so many years later. And one of the reasons I've been wondering why is because we just simply can't accept the simplicity behind storing our data. Storing data is not hard. And when you think about data lake, it's not hard either. So I'm going to relate this to you through one of America's favorite pastimes. And it's not baseball, it's not football. It's about losing weight. So who would have guessed? It really is not that hard to lose weight. And not that I do any of these things, but it's a $1 billion industry. We have $1 billion industry for pills, $1 billion for books, and for Oprah deals, about new chai lattes. And so why do we have these things when it is so simple? I mean, really, to lose weight, it's what? Two things, right? You exercise, and you eat right. That's all there is to it. So I'm going to be relating this to you for the data lake in the same way. There are some simple things you have to do, and you have to accept them, and you have to do them in order to succeed. So as part of Cisco's journey that we've been doing since early 2011 for our data lake, I'm going to relate no products that we've used. There's nothing to sell. This is simply our experience and those fundamental things that were necessary, which includes just setting up your access management, making sure that there's governance, security, understanding how and what data you're going to store, understanding the purpose of having a data lake at all, and understanding what that data lake really means. Because data lake is one of the most overused terms and words. I think, to be frank, it doesn't mean the same thing to most people, and we can't really get a sense of agreement on what that means. So when I talk about data lake, I just want you to understand that I'm talking about a place to store data. Lots of data. So much data you wouldn't believe, right? How big is the universe, Douglas Adams? I can try and throw in some references too. So data lake is just our place to store lots and lots of data. But to be clear, it's useful enterprise data. And this is the most key aspect of when you're building your data lake. Useful enterprise data. You can have very useful non-enterprise data that one guy's using. Or on the other side, you can have non-useful enterprise data, which everybody seems to be using but has real no purpose in your lake. So when you think about what data lake means for this presentation, I just want you to remember it's the place where we're storing a lot and lot of useful enterprise data. And there's nothing wrong with that. When I was looking at the faces, some of the faces are happy for data lake, some of them are not. But the point to remember is that Hadoop is for three things: your storage of data, your execution engine, and for the management of your resources. And the storage of data is one of the most primary components. So there's nothing wrong with storing good data. But unfortunately, we run into some problems. One of the biggest ones, and one of the first things you should do if you're starting out just with your Hadoop system today, or whether you're already well embedded, is to understand the purpose of your data and how you're going to access it and structure it. What place does it sit in your enterprise architecture? And so with that, I want you to understand that a data lake is not just a singular concept. It can be multiple lakes. It can be the reservoir where you have now some maybe MDM thrown on top of your data. It can be well organized and structured all the way to the point where it's like your DW, right? Your data warehouse where you have extreme models defined. It can be just ponds. So you might have your central data lake with multiple ponds on the outside where you're saying, okay, my SOX data guys are not too happy with me putting the same data into the same system, or PII data where everybody else is going to be accessing that same system as well. So you can have multiple areas where you're putting this other data. But this data swamp is the term everybody's heard and everybody understands that you will run into if you do not do it properly from the beginning, which is setting an ivory tower to say that I'm going to have data accessed all these different ways, but it's not really realistic. So as part of the first thing you should do in setting up your data lake or in understanding what you need is to understand what you're going to be providing, what your user is going to be consuming from your lake, and then not changing from that. So this is the first slide and sort of where we were in 2011. We had just gotten Hadoop. We were super excited. We knew that we had all these great applications to develop, but all of our applications were using the same data sets. So we had the same data coming in again and again and again. But more than that, I just drew 4 sources, but you can imagine how many there were. We were connecting to those sources in the worst way possible. So we had developers pulling billions of records over a single JDBC connection. We had those same source systems with scoop jobs running that were completely unoptimized. We had splits that were on 2 modes, or conversely, like a huge cardinality that had very unequal splits. So we were pissing off our DBAs like very majorly. All the data being brought in again and again in the same way, in different ways. There was no structure. We had just set up the Hadoop platform already. It was having the same data sets exploding again and again inside that platform. If you think about your traditional warehouse, maybe 5 TB didn't seem like much for a table, but in Hadoop, okay, we can store as much data as we want. Well, imagine you brought 5 TB for a single table, well, times 3, okay? Now, how many applications are using that same table? Oh, yeah, okay, we had unlimited storage, but now it's just getting beyond the point. And this is really where the rainbow of problems is coming from that I was talking about. We can't have this sort of situation going on. So the original goal and why we got started was sort of to do this picture on the end. We want a single type of data flow. We want a singular set of pipelines so that maybe the color shouldn't be the same, but from each of the data sources, we're applying more native connectors. We have structured, repeatable, without redesigning code, again, ways to pull in data. And I'll be talking about that. It's called data on tap soon enough. The data that comes into the data lake is accessible by all of my users, and it's useful enterprise data. And this is simple. This is simplicity. Okay, work out, eat right. You have to go with simplicity here and to understand we want data to be consumable in the same format it was before in a single place, without having to yet again go through the same problems that we had for when we set up our original data warehouse. And of all of those things I've already mentioned, one of the most critical is data on tap. So this is the concept we have at Cisco and one that makes our data lake really viable. So when I talk about data on tap, it's not, it's not a beer or anything, but what the concept is something similar. If I want a new piece of data, or if I want a complete new data set, like the entire database, it should not be a rework for my team. I shouldn't have a developer that's sitting there coding for each one. I shouldn't get contacted even about that. What we're going to be talking about is a metadata framework, which is the one above, where I can simply put in that this is the object I want, and it starts flowing. The data is now available in my lake. Now there's a series of governance, and there's a series of security mechanisms we'll get into and how to manage that, but the basic premise is the same. I want data to flow, and I don't want to have to, again, redesign anything. I don't want to mess around with my DBAs and the source systems where data's coming from. Just want to collect it. Provide all useful enterprise data. I don't think it comes again in the slides, but I'll say it for that last time. Metadata management, though, if anybody has a Hadoop system, how difficult is it for you to find data in your system? Unless you have a very single-tiered user system where you don't have a multi-tenant platform or you have a very well-defined series of use cases, it is nearly impossible to find what's inside your Hadoop system. So having a data lake just for the purpose of metadata management might even be enough. You will be able to find what is inside your system. I know that there were cases for us, at least, where we had supply chain data that the same teams wanted again and again and again, same for services and software and install base, but they had no way to find it. Now we have a central portal where teams can go and say, look, I'm looking for this table. Yes, there it is. This is the person I need to contact to get access. This is the workflow that needs to go through. So metadata management becomes critical and was one of the most beneficial things we were looking for in starting out our data lake. But once you get started, there are going to be a couple decisions you have to make. I've only listed 3, but there are so many. One of the first is really going to be, do you build or buy? You're going to be presented with any number of different solutions you can use, and again, I'm not going to talk about a single one in this deck. You can feel free to talk to us and ask what the opinions are, but if you decide to build in-house, you'll have a very customized, tailored need. You will, unfortunately, have to build all the basic connectors from scratch. There's a lot of benefit to going with the buy. You might feel like, okay, then I have to be stuck with that vendor, but at least I'll have all the capabilities up front. Data lake or data reservoir, I already talked about this, but you have to decide what you need. If you want a data lake where you have one-to-one, unchanged data coming in from your source system, which is accessible exactly as if it was from the source, that's great. But replace data lake and data reservoir with any particular word you want. Data lakes in particular, which is probably one of the most common things. And then self-service or managed. If you have a director here that's visiting, or if you go talk to them, they're going to talk about speed, right? How fast can I get my data into my Hadoop system? And here's where you really have to fight, because useful enterprise data is not going to come in by itself. You're going to have guys wanting to push in their particular log files that have nothing to do with anybody else. They're going to want to pull the web data, the web service data. They're going to want to pull their streaming data that might be great for them, but has no purpose for everybody else. So there are benefits going with self-service or managed, and it depends on what you want to do with it. That is how you will make your decision going forward. For Cisco, I can just tell you that when we got started, it was early 2011. So for us, there really was no solution that you could go buy. When you wanted to talk about data ingestion, if you wanted to talk about data management, there really was no good tool. There was more for reporting, more for our guys who were doing machine learning and data science, but data ingestion and data management, there really was nothing. Times have changed, and now there are plenty of good tools. So they don't do everything, and they do have gaps, but at least they will provide for the basic need. Data lake or data reservoir, even I feel still strongly on this one. Go for a data lake or a couple smaller data lakes on the side as well. If you create a data reservoir, or if you create something similar, you are going to turn it into either a swamp or turn it into something that's useless. Create a one-to-one with source, exactly what you had. Don't apply MDM. Bring in your data exactly as it was, and understand that that's what you have. Then you can have things later on outside of the lake or not considered as part of the lake, and it will be useful for your teams. Eventually, you will run into the problem where if you start changing the data after it's landed in your Hadoop system, that somebody still wants the source data. They want it the way that it was, and they don't want you messing with it. So just keep it and let it flow in. Now, creating multiple lakes makes sense still because of the segregation for the requirements of data. One of the key challenges you'll run into from the beginning is, do I want security by design, or do I want security atop what I already have? And creating a security by design measure is much better, so I'll get into that a little bit later, I think. But separating out who's going to be accessing what data in a multi-tenant environment does become critical. And then finally, self-service or managed. We went for managed, and we just decided we're going to have a central team that is pulling in data. I'm very proud to say, like, we have a week turnaround time. Now, for a startup or for a bigger team, that may not be that great, but you have to understand, getting in data and understanding how it's going to be used, classifying it, having the proper governance, those are all things that you need to manage from the beginning. Later on, or if you have a very mature user base, they'll be able to bring in their data, but we went with managed. So data on tap. I started talking about this, and I want to get into what I mean on this a little bit deeper. So when we talk about an automated ingestion framework, even if you're not sold on the concept of data lake, this is the one thing you should sort of take away. You can build this for your organization as well. If you want a data on tap mechanism, you build out a series of controlled ways to extract data, to organize it, and you build it for the most common sources. So you'll have CSV files, I'm sure you'll have relational sources, Oracle, Teradata, MySQL, you name it. Streaming, web services, so SFDC, you'll have any number of common sources that need to get pulled. And unless you provide your user base, your developers or your engineers or even your business analysts who might need data in Hadoop, unless you provide them this data on tap mechanism, they are going to have to go and do whatever they're going to do, and it's not going to be pretty. So you build for those most common use cases and you employ your best practices. So we'll get in deep into security. Governance is one of the hardest aspects because everybody disagrees on who owns the data. Once it's inside your system, well, it's in your hands, so now I own it, right? But think about it in the sense that you need to maintain the governance of the actual source system where it's coming from, and that should be the rule of whoever's creating your lake. But the typical process that I've seen is you have to figure out what source you need, you design, you develop for that, you implement it, you bring in your data, you finally have audited it, made sure that whatever you pulled was the same, and you sit there and you normalize for quite a while to make sure that your regular incremental ingestion is working. But the way that we built this data on tap mechanism is just really, I add some entry into metadata or a web service does that, and then I go do whatever I want. So I get coffee. Now I want to show you just how simple this process sort of works in our automated framework. So I made it as simple as possible. Simplicity today, guys. So here I've got my user in the bottom and a cloud system. So that could be me, or it could be an automated service. Something new has come into a warehouse and I need that also to flow. So I make that entry into my metadata repo, which for me is like an ODS database. Then after that entry is there, I'm done. I go walk away, I get my coffee or whatever. Whether it's a one-time thing or whether it's a every hour or every 20 minutes, it doesn't matter. The scheduler that is kicking off all of these jobs goes and talks to my Hadoop platform and says, look, these are the groups of jobs I'm expecting you should launch. My Hadoop platform says, I don't know anything about those, but okay. Goes, talks to my metadata repo and says, yep, okay, there's all the information I needed. What is the source system? What is the primary key and unique key for that table? How is it that I'm going to even go and structure that data pool? Everything from that one entry I made is figured out from my metadata repo in that Hadoop platform. Metadata repo passes the info back to Hadoop. Hadoop says, okay, whatever source system we're talking about, this is the information I'm looking for. This is where I was last time, where I had last pulled my data, whether it was an incremental, then I'm giving it the last date that I pulled. If it's a truncated reload, I need all the records. Here's the optimization for that. And then I stream it in over multiple pipes into, or maybe stream is the wrong word, but I pass it over multiple pipes into my Hadoop platform in the best way possible. So this is the data on tap and the data ingestion pipeline that we had created. Now, hidden inside of this are all of the steps where we can validate as well. Okay, how many records was I expecting from the source? Did I get those? While I was transmitting the data from that source to Hadoop, was the data getting transmitted appropriately so that I received every single byte that I expected? Once my data's landed, have I audited it appropriately? So all of those things and all of those steps are from our single data on tap mechanism, which some vendors are now providing. So think about building such a system for your users today, even if it's not going to be in a data lake and it's going to be into their application directory, or if it's going to be just for their use. Understand that you can build such a system and it will provide extreme value. Whether you choose to go with the data lake implementation where it's going into that central pool of data and useful enterprise data, then that would be awesome. So file system layout and security. So, lose weight, you just have to eat right and exercise. Understand how you're going to store your data. And one of the most common ways and one of the most important things you need to understand about getting started is you're going to have to control and segregate your data. How you do that is going to be very complicated because multiple users are going to want different data sets, even down to the different column, down to the different row. How you implement that is going to be tricky. So design for the most common scenarios first and then work up. I think I mentioned SOCs and PII data are some of the most common places where you're going to need security and control. So these can be simple cases where you can segregate out completely to different clusters or to different areas of your cluster for access. Understand the purpose of the data you're importing. Whenever you have, this is the simplest thing, like it feels silly to say, but when you're importing something into your lake, do you understand how that data is going to be used, or you just put it into your Hadoop system? Document, whether it's just a single line of which team is using it and the reason, the application that they're developing to build with it, document why that data is coming in. If you don't, you will forget, or somebody will leave, and the data will become just there. You're going to be continuously maintaining it and never leveraging it again. That same 5 terabyte table I told you will explode, and you will be storing a petabyte before you know it of useless data. So store data in the format it's going to be consumed. So if you have teams working on Parquet, maybe it's best to store in Parquet. If you have data that's getting used by a team in a CSV context, maybe it's best to store in CSV. The purpose of this store data in the format it's going to be consumed is not so much just the file type, but the way that it's going to be consumed will drive how or what tool you will use. So keep that in mind. Can't please everybody. I remember some of the first cases we were working with Hive initially, and it was really early. Partitioning was simple, and one team wanted it partitioned on this column, one team wanted it partitioned on a different column. You won't please everybody, but try to understand the most common or most productive use cases from your data and build for those. And finally, understand the security impact. So we've heard cases of, I won't give name, big branch retailers and dating sites maybe who have had security breaches and problems after that. So you will run into problems eventually, whether they're internal or external. You will have a breach of some kind. It might be small, it might be big. Plan for the worst, plan for success, plan for the worst. Maybe I have to steal that, but understand the security that's going to be required from a legal point of view as well. If your data is breached today, how is that going to impact you? And building that security by design is going to help prevent this problem, but it's not always feasible. So at least segregate out the security measures based on the type of data you're going to have. You're going to want to talk with your data architects to understand what is required. So finally, I want to dive into data lake just a little bit to understand how you're going to segregate data, or at least how we did at Cisco. And it's pretty simple. If you see this file system layout, it looks almost exactly like this. There's a couple layers of complexity hidden, but for the most part, it's this. You have enterprise data. Enterprise data consists of, I'm scared to use this, but enterprise data consists of all of these different subject areas. Each subject area has that type of name inside of our Hadoop HDFS. So in the map RFS, if you start, CD to this, CD to that, CD to that, this is pretty much what you'll see. You'll see that there's a supply chain group. You'll see that there's a reference and sales. And if you go into sales, just as if you went into any of the other ones, sales breaks down into the different subject areas. So I've had business analysts who've told me, oh, I found the exact data I needed inside your Hadoop system, just because it's organized in an easy to understand fashion. So all of this layout, you can say, is also accessible from the web. So they can start scrolling through and start looking through, this is the data I was looking for, I don't know what source system it's really coming from, I think this is what I need. But understand that if you try and put in too much complexity, if you say, okay, if it's coming from this database, I'm going to segregate it by this, the schema, and then the table name, and I'm going to put this logical grouping because that's how the data actually works, you're just going to confuse people. When we started putting in the data, we applied all of that in our metadata repo. We took all of the good classification that we would probably agree should be there, and we put that in our metadata repo so that if we really want to find out the classification, we can go do that. But somebody who's going and browsing Hadoop, if they want to understand where the data is, they'll be able to go by this mechanism. For Unix level control, this is pretty much how we control the fundamental flat file that's sitting in Hadoop. So we have different assignments of data. Everything either ranges from a public data, which anybody who's got access to the platform can access, or it's restricted, and we call that private. And for the private groups, each one is different. So if I've got channels data, or pre-sales, or post-sales, or just regular sales, each one of those has a different Unix group that's sitting on top of it, and it's restricting the data. So the multi-tenant environment that we have leverages generic users. So if I'm on one team, I have a generic user. If I'm on another team, I have a different generic user. And each one of those is a lot of different permissions. So if I want access to this pre-sales data, if I want access to my install-based data, I have to get the appropriate requisite group to that data. And the data that's sitting there as a flat file has the appropriate stage mod. So if everybody understands that, I didn't put a decipher for this, but read, write, execute is for the user who owns the data. The middle three, read, write, and execute, are for the group assignment that you have in a Unix file system. And the last three are for the any user, anybody else. So if you see here in this public, the person who owns the data, the admin account, will have read, write, and execute. Everybody else just has read and execute, which means that they'll be able to look at the data. And then finally, for the restricted group, the final three, which are just dash, 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 unless you're inside the group, you won't have access. So this is the basic premise, and you can see this metadata architecture is extremely simple to define where data goes, how it's accessed, how often it's refreshed, when it got refreshed. I didn't omit any columns, I just took our actual metadata repo for that component and put it here. So they're very short tables, they define things very well. We're gonna have a lot of time for questions, don't worry. So once this is implemented, we're done. And when I was talking about putting in a single table, so there's this one driving table, I make one entry into that one, and I'm done. If I have a new Oracle table, if I have a new flat file directory that I want to import, like maybe I've got my Cisco.com logs that are getting clicked. Every time somebody does a click, that generates a log. If I want that data to be brought in, I just have to make one entry there, and I'm done. So that's the type of framework we've had. And no matter what I put in, it's structured already based on these other tables, where it's going, who gets access. If there's a data governance flow, then I've got multiple layers where I can get approval. When somebody wants to subscribe to my data, there's going to be a central portal where they can go and they'll do their checkout process, like you're shopping on Amazon or something. They will have internally a system which then routes that through the flow and then finally attributes the access accordingly. So it's a very simple system, but we had looked at the alternatives of building in the complexity we thought that an engineer might like, but ultimately keep it simple and people will use it and it will not break. So then I want to get into the enterprise processes that drive that, because the biggest lever by far is this automation. When we talk about building in automation into our platforms, it sounds great, we don't really know what we mean, but what we mean by automation is a way that we can have as little human touch as possible. That's really all automation means. When we talk about the automation of data workflows, data pipelines, I want you to understand that it relates to just the simple ways that we can have data accessed and data managed and data brought in. So for automation, we have automation of the services that are itself running on the platform, the automation of the data being brought into the Hadoop system from our scheduling system, automation of the users who are going to access at particular times. And I'm just trying to think off the top of my head, there are so many different systems we built in, but this is by far the biggest lever, because if you have automation, then it means that you're going to have as little human touch as possible. Self-healing is one of the biggest things. Imagine you're bringing in data and something fails. The JDBC connection string was down because TNS listener wasn't active. Something pathetically simple. If you have such a scenario, you don't want your entire process to fail. So as a result, have self-healing where the process can get restarted. And if you look at some of the other systems like Kafka, it fails the first time, then it waits a few seconds. Then if that one fails, it waits a few more minutes. Have something similar where it's not just trying to bombard your source or bombard whoever's trying to access the data, but it's waiting and it's got some heuristics to understand how it's supposed to restart. Self-service, I mentioned the checkout procedure. This is going to be one of the most important things, is subscribing to your data. So even if they're able to find it and they're able to say, look, this is the data I want, I can see that it's there, how do they get the subscription to that data? If that process itself takes a week, then you're gonna have some angry people. So understand that self-service doesn't mean bringing in data, but it also ties in with that, because you need a way to get the data in without actually exposing it to them. So one of the things we were exploring also is automatic validation, this automation of the validation for whatever they want, setting everything up into that metadata repository, maybe even staging data for loading, but it's not accessible to them. So if there's no data steward approval, or if the engineers are saying, look, that data really doesn't belong here, then it won't actually be brought in. So that subscription is incredibly important. It will drive your adoption for your data lake. It will drive how people are leveraging the Hadoop platform. And then finally, the data catalog. So we talked about the web portal that we had built. This is just a simple way for users to go and browse through your data, browse through the exact objects that are there, understand who are those contact points. The data catalog is going to include limited amounts of metadata. So I think some of the cool solutions I've seen from vendors today can do profiling of that data and can understand what is truly there from a data perspective. But you won't have a data catalog necessarily in your Hadoop system because it was there in your source system. So if you had an extremely nice logical data model or physical data model that you spent a lot of time working on in your data warehouse, you're not going to rebuild that here in Hadoop necessarily. You're just going to leverage whatever you already have because it has the definitions. So just be sure that if you're going to build any kind of data catalog, maybe just make it a portal which exposes the data that you already have from those other systems. And then I want to talk about the use cases that drove a data lake. So I mentioned it already, and I was just discussing with Jim on one of our install base opportunities. This was one of the first applications to be on Hadoop itself. And we had install-based data, which was, huge. It was only a couple billion records. It was very small by what we're dealing with today. But at that time, we wanted to make sure that that data wasn't brought in again, because the next day when we had another team join on the platform, they also wanted the same data set. So annuity opportunity was one of those first things, and it was an exploration of how the data is going to be used in a way that we can determine incremental upgrades for customers, whether it's for a router or a phone or whatever. If there's a software upgrade, then we need to communicate that to our client. If there is a upsell opportunity, maybe they bought an old version of a phone and it's been 3 years, we can sell them a new one. So this was one of the first ones. This use case was operating all on their own. They were in their silo. We had another use case come in. They also wanted to look at manufacturing defects and quality information to say, okay, that version of that phone which we had sold to that customer, that had version 1.0 of software. That bug which is annoying them got addressed in version 1.1. So understanding how the bugs relate back to the version of software and specifically manufacturing defects on the product itself. So they needed the same data set. So we then said, okay, look, this is going to be a ripe use case. We'll start out. And we started seeding our data lake. And when we were seeding it, we had no standards. We had no way of exposing to our clients the information that we have today. But we started building up. And what we did, if I were to flash back to those original slides, was we decided what we wanted. We wanted source similar data, one-to-one. And it was going to be an exposure of exactly what we saw from that source system. We were going to provide it in an easy to understand context, so it's going to go into these directories. Now, those directories have changed today, and they're much simpler to understand, but at the time, it was convenient. So all of these teams that were using the data for different purposes and for different things have now exploded, and each one of them is coming to the data lake to leverage that data in different fashions, but getting exactly what they need. So if I look at, for example, churn analysis, well, Cisco has a product called WebEx, which is super awesome, of course, but it has a poor churn rate. And if we were to expose that churn rate and just bring it down a few percentage, that'll save millions and millions and millions of dollars. So those guys who are accessing that data are looking at probably about 20 terabytes of data. If I were to pull in that same churn analysis data again, 20 times 3 times now 2, it will be a huge, huge amount of data that's just getting wasted. So I'd like to talk about these use cases more one-on-one, and if you have something that resonates with you, that's the one I want to talk about. So come visit us at the booth. Be sure to check out Jim's signing. But with that, I want to just take a bunch of questions because I'd like to get a feel for where you are with your data lake, what your success is, where your challenges are, and tell you how we address those if we did.
Ask a question that deals with your comments about self-service, about the metadata, data access layer, although I think I got that term wrong. And then a line item you had in the earlier slide about having, storing the data the way you want it to be pulled. If I understand, could you explain more about the metadata data access layer? Because I thought what I heard is you're indicating that that's a place where users can go to find not only information about the data, but how to actually get to the data they need. That strikes me as being a lot of work. So a great idea, but how do you actually get to the point, or do you actually get to the point where users look at your metadata and they can go directly to queries of your data?
Excellent.
If so, are you not structuring your data? To me, that strikes me as you're trying to structure your data maybe more than is easy.
Yeah, so the question is about metadata management and what purpose does it serve? And actually, you're right on point. So when we built this metadata framework, it was originally for the engineers who were building the data on tap mechanism. And so it was a complete exposure of every element of our Hadoop framework. But then that's not going to be the easy thing for a business user to understand. So then we built a portal, and that portal simplifies the metadata framework to something that they can comprehend. So if I'll give you a couple examples. Let's suppose that I have WebEx data. WebEx data comes in different forms. You can have BRM, which is paid subscription, or you can have I sign up by my email address. We have Bliss, which has just enterprise customers. We have SaaS. Like I can keep going. We have so many different types of this data. And if you go into our the actual metadata catalog, it will be impossible to decipher. You won't understand what's going on. But we bubble that up with some logic through our portal so that if you're looking for WebEx data, it's sort of like you just drill down and you can say, look, I'm looking for this data, I'm looking for this general type of data, and then it exposes back to you what you need. So from there, you can go as detailed as you want.
Does it expose the metadata about the data you need or the actual data? Right?
Just metadata.
Okay, all right.
So if you want to see actual data, then there is a sort of a preview for available things. So you can't see credit card information, right? But if you wanted to see something which is not as sensitive, however it's classified, you might see a few records. But it will show you just the details about that object, and it will give you as much as you want. So you can keep drilling down. If you want to see the exact HDFS path where that data is sitting, it'll tell you that. The exact permission set, the, unfortunately, data stewards' names who are behind that data. So you'll be able to see just as much as you want, but it all boils up to a level where if I have just no expertise, then I can start browsing.
Would it then give you insight on how to join different data sets of interest for analytics?
Only if the information came from the source system. So I'll give you an example. We pull a lot of data from Teradata into Hadoop, right? But in Teradata is where we define our logical data model and our physical data model, which exposes how to join all of these entities. We do not replicate that into Hadoop. The reason being, there's no point. If I want to go and join those objects, I can go talk to a subject matter expert who understands exactly how to do that, if I just don't want to look at any physical object. Or I can go look at the LDM diagram and say, look, the object was copied one-to-one, remember? It hasn't changed at all. All the columns are there, all the fields are same as there as they were in Teradata. So I can just go look at that LDM and say, yeah, this is Hadoop, this is in Teradata, but I'm using the same model because the object was copied the same.
So you're not doing schema on read?
We are not doing schema on read. The definition of whatever we had pulled is the same as it was at source, and it's exactly copied that way. Now, not everybody needs all those objects. They don't need all the columns, for example, from my table, so they won't read all of those, but it's available if they want them.
Are you doing that without a large amount of transformation of your source data?
We do no transformation, that's what I'm saying. So it's all one-to-one. So the original staging layer is all one-to-one with the source. So from that way, we were talking about this earlier too. Suppose you want to do some data cleansing and your data is not really in the proper format. Suppose your rules change. If your rules change and you've already done data cleansing when the data landed in HDFS, you are screwed because then you're going to have to go repull the data and reanalyze how it's supposed to work.
So your source, okay, I have to plead ignorance here. Your source data is exclusively Teradata relational?
No. We have Teradata, Oracle, MySQL, flat file systems, streaming for log data, any number. But come talk to me, I'll help you out. I'll be at the booth.
That was my question. I was gonna ask that.
Are we snapshotting the data? So we're doing a couple things. So I think the question is about how do we handle changes maybe in the source, like they add a column, or if there's an update, maybe how do those updates flow? So we built an entire mechanism. This is still part of data on tap, and thank you for asking that because I didn't explain. When data comes in, we upsert. So if there was a change, then we update the record that's existing in Hadoop. And when I say that, I mean we update that record. So we delete the old one, we insert the new one. If it's just an insert, then it's an insert. And if it's a delete, then we have what we call a DIU. We prefer to preserve history. So if there were records that are deleted, we prefer to just keep them available. But if they absolutely have to be deleted for some reason, then we create a table with the unique key column that identifies that record. We have a DML flag which says insert, update, or delete. And if it's a delete, we join back to that and remove the record. So the merge process that we built does just that. We provide it in our metadata repo, the unique keys for that table. Then we say, look, when you get a new record that comes in, join on those same keys, and then look at the new data and the old data. If there is new data and existing data, then it means it's an update. If there's only new data, then it means it's an insert. So from that way, we're able to identify the records. And that merge process happens through Spark, which is very fast.
What is the format of the file?
What is the format for the file? So we're looking at a number of different file formats. A lot of it is in text because of the way that Scoop works. When Scoop lands the data, which we still use today, you can use Scoop in effective ways, then it lands as text. Then it can be converted to ORC. So ORC is a good file format because it's extremely compressed, which was one of our tenets. We want to reduce the amount of data that we have in the system. Parquet is also very good, and Parquet plays nicely with other tools as well. When Drill is reading, we've had more luck with that. So I go with a mixture between ORC and Parquet. I haven't seen much use for Avro. There could be an entire discussion for which file format to choose, but if you're picking for my personal favorite and as a general broad thing, it would flip between Parquet and ORC based on your data requirements.
You said you update records in the files?
Sorry?
You also said that you update records in the same files? Or
No, it's not the same file, of course.
you just append the changes?
So what ends up happening is there becomes a staging table where we merge all the existing data and the new data. Once that is done, then we swap out the new data and the old data. So there's a one-time swap that will happen for each of the updates.
So the same question, you have multiple tiers, you have the ingestion, the source that you try to take it, and you have the management inside of it. And that's how you see the data flows for you. You finally get into the data inside of it.
Correct.
I have another question. Many of the clients, I see your point of view of the enterprise nature of it and the usability perspective of it. But there are many other clients that we work with, they would say, we need to move in the data because we are sitting on a golden mine and we don't know the nature, let's say the CDRs, cognitive records. And I need to move all of that data into. Earlier we had the opportunity to mine it and understand it, get the insights of it to see the useful of that data. So I want to move in the data because I have a Hadoop, I want to move it there. And so
Oh yeah. So I know where this is going, and I can answer this question. The question is about, look, I got data, I know that it's probably valuable, but I don't know that it is. And even if it is very valuable, I don't know necessarily how to use it. I want to get it into Hadoop so we can make the determination, and then from there we'll proceed, right? So here's what I did. Data comes into Hadoop, into their application space. If they want to go play with that, for example, with log files that we had been ingesting on the Cisco.com clicks, it was sort of a, the dark web side of the Cisco.com. So once we had that data flowing in, they wanted to go do that analysis. They proved that it was extremely valuable. Once they did that, I appropriated it. And I said, yeah, it's going back into the data lake because this data we know now to be valuable and others will use it.
So you would create a sandbox for those things?
So I don't like this term sandbox in Hadoop. A lot of people use this because in the Hadoop ecosystem, Yarn manages your resources by default. So it's not that you need to create a sandbox, which is a separate area. You just create them a new mount where they can store their data. In the HDFS file system, especially as MapR has it, it's extremely nice. You just create them a new directory, and then their data's in there. Their compute and number of resources that they're assigned is all governed through Yarn. So they can't possibly impact everybody else. So you just create them a new account on your multi-tenant environment. Once they've proven that it's valuable, if they need to be upgraded to a more beefy account, then you can do that. And you move the data from their portion of the file system into the commonly accessible area.
So do you use the same strategy to deal with IoT data and real-time data? Anything IoT related or real-time data, you do the same thing?
So there are only a couple ways you can get in actual NRT. So NRT, like for us, is using Golden Gate to pull data from an Oracle system. If it's streaming from a website, we either do it through microbatch today. I'm talking about today. So either we do it through a series of microbatches, which is actually not truly NRT or streaming, but you have to wait like 10 seconds or something to get the data in. If I wanted to do actual streaming, which we're looking at more of a messaging bus service where like a Kafka or a MapR Streams is sitting there and all of the users who need that data subscribe to that service and pull it. But wherever it goes in the context of data lake, it will go into a directory and the data on tap mechanism is just going to be the Kafka subscriber, for example. So I'm going to have all of the information I need to be able to ingest that data into my HDFS.
How are you throttling the data ingestion into a cluster in a multi-tenant environment?
How am I throttling the data?
Yeah, so with respect to if you're running jobs on the multi-tenant, yes, we can do resource allocation and throttling. But what about the data coming in by NFS? How are you going to throttle that if you have tails and everything?
So we're not Comcast, we don't throttle, so sorry to hear. But so what we do is we pick out the times that it makes sense to pull data. If the data is getting updated in my source system at 2 a.m., then I don't pull at 1:59. That would be just ridiculous. But based on how the data is getting updated in the source, it determines the possible frequencies. Even if the data is getting updated at 2 a.m., it may not make sense to pull the data except on a monthly cycle because my jobs are quarterly. So if the requirement of that data only needs the data quarterly, then I would just pull it at that frequency. So I manage the ingestion rate based on the requirement and when the data is getting updated. And with that, I think my time is up. Thank you very much.
Oh.